do some exercises. I'll give you differentiate. So I'll give you f of x, or sometimes I'll write as y, and you will find out f prime of x, or equivalently y prime or dy over dx. Okay. So first function, sine of x raised to the power alpha. So we'll use chain rule, differentiating sine of whatever that argument is. So let's call it sine of u, where u is equal to x to the alpha. So d sine u over du, that is cos of u, but u is x to the alpha, so it becomes cos x to the alpha. Okay, times the derivative of this. Derivative of this is alpha times x power alpha minus 1. Okay, a better way of, neater way of writing it will be alpha x to the alpha minus 1 cos of x raised to the power alpha. How about this one? Derivative of this. Have you done this? Y prime of x is, the derivative of sine is cos. Okay. Now I should differentiate the argument. If you are clear, right? You remember the chain rule. If you are initially you are not confident, you use u and v the way I was writing earlier. Now I should differentiate this. Differentiating a square root gives you 1 over 2 square root. Okay? So that gives you 1 over 2 square root of 1 minus x square. So see, it's a nested chain rule I am using. Now I should differentiate what's inside. What is inside? 1 minus x square. What's the derivative of it? Minus 2x. That's your answer. So I'll write it down a little neatly. You should write 2 cancels. There's a minus sign. Minus x over square root of 1 minus x square times cos of. Is this correct or you get something else?
Where did the minus 2x come from?
Differentiating this.
X square.
See, sine root 1 minus x. Suppose you had just sine of 1 minus x square. Then you, when you differentiate, you will get cos of 1 minus x square. Then the derivative of 1 minus x square. It gives you minus 2x. But now you have sine of square root of 1 minus x square. So when you differentiate this, you get a cos. But now you have to differentiate the square root. It gives you 1 over 2 square root. Now you have to differentiate what's inside the square root.
You have to use chain rule 2 times.
Of course. See, forget all this. What is the derivative of 1 over square root of 1 minus x square? Let's take a simpler problem. If this is not clear, then take a simpler problem. Let's say f of x is square root of 1 minus x square, right? I'll have to use chain rule. So f prime of x is equal to 1 over 2 times square root of 1 minus x square times minus 2x. Do you understand this? See, if it was just square root of x, then it is 1 over 2 square root of x. But it is not just square root of it, it is square root of some other function. So I have to use chain rule. It's a function of a function. Is this clear? So here, now is this clear? I submit. Okay. So if this is clear, then move to the next one. Some function z of x. So z is a function of x which is sine inverse of square root of 1 minus x square. Let me just go back here. So you see here I have given this function. What I should have done is told you the domain of the function, right? Can you tell me what should be the domain of this function? Can x take any possible value? If x is larger than 1, it becomes?
It has to be minus 1 to 1.
It has to be between minus 1 and 1. Okay, it has to be between minus 1 and 1.
Or equal to.
Equal to is also fine. If it is equal, it becomes
It
0.
can be.
Huh?
It can be.
It can be. The derivatives may have an issue in principle. Okay, that you should check whether there is derivative having an issue there. Is f prime of x, if you take f prime of x and you take the limit x goes to plus 1 or minus 1, you get a finite result or you don't. Okay, that will tell you about any restrictions that you might want to impose. So क्या हुआ last one क्या हुआ? हाँ ये करना है. Okay. So what is the derivative of z? So derivative of z is, what's the derivative of sine inverse of x?
1 over 1 over root 1 minus x square.
So just let us do it here. Sine inverse of u. Okay. So that is u. So for me now u is equal to square root of 1 minus, what happened to this? Okay, so I am taking u equal to 1 minus x square. I am going to use chain rule. So I have then d over du of sine inverse u times du over dx. Is that okay? Now what is d over du of sine inverse u? This is
1 over
1 over
root 1 minus
one minus u square. Okay, अभी u रखते हैं.
ऐसे ठीक है.
Okay, times du over dx. Okay. So let's put it here. So this is what, right? That's the derivative of. So let's put here. What is u? U is, what is u square? U square is 1 minus x square.
1 minus.
Okay. Squaring it removes the square root. So 1 minus x square. So you have 1 minus x square. So 1 minus u square is
Minus
1 minus u is 1 minus x square
This is x square.
is equal to 1 over, this becomes square root of x square times du over dx, the derivative of u. This is 1, what is this? Do you agree? Huh? Okay. So this is equal to my 2 cancels. Okay. You have x over, what is happening? There is a minus sign and there is 1 over.
Root x square is x.
Okay, up to here it's fine.
Root x square is x.
Root x square is x.
Minus x over x minus 1.
Minus 1 over. Is this correct? No, this is not correct. Okay, before I tell you what is not correct here, let me first tell you the domain. What should I take the domain to be? What values of x should be allowed? So if it was just sine inverse of x, then x domain should be, I can take domain to be
Minus 1.
minus 1 to 1. So the argument of sine inverse can be taken to be from minus 1 to 1, or should be taken to, or any smaller part of it. Okay?
It should be
But then if this has to lie from minus 1 to 1, first I should worry about it being real. So I should restrict x between minus 1 and 1. So that will be guaranteed. We are lucky. That if x is 1, then it is 0. X is less than that, it's a number smaller than that. But x outside will give you a problem.
So it can never be.
This is okay now? Okay?
Yes.
Now let's see here. So these are the values which are allowed. X over square root of x square. We have written here wrongly square root of x square as x.
It should be root x square inverted. It should be plus minus, right? It will be plus minus.
Huh?
Can it be plus minus?
No. How can it be plus minus? See, you are not solving an equation. You are not saying y is equal to x square. Then x, what are the possible values? Then you write this.
Then what's wrong?
But here you have not done that. You have been given square root of x square. There is a positive sign in front. There is nothing to choose. So what is wrong? So from here to here, you make a mistake. What is that mistake? No mistake? Okay, let's see. Square root of x square is equal to x. That is what you are saying? Let us take x equal to minus 1. Then the left hand side is square root of minus 1 square.
For all positive.
And the right hand side is 1. Minus 1. Okay, this is left hand side. This thing. This is this thing, right hand side.
Oh.
This is square root of 1, which is 1. This is minus 1. Not equal.
So the domain should be.
No, domain is there. That's fine. There's not. See, your mistake here will not start fixing your domain. Domain is fine. What I have told you is not a mistake of your domain. Your mistake of algebra. I've just shown you that this is not equal.
But if domain was 0 to 1, then this
would be correct.
But it's not.
So in general, x square root of x square is not equal to x. So let's see if you are not following. So this is fine, right? You understand what's wrong? So if you understand what is wrong, then let's understand what is. Is this getting captured in camera, by the way?
Yes.
Okay. X square square root is equal to, if x is positive, then it is equal to x.
Yes.
Agreed? And if x is negative,
Minus x.
then it is minus x. Very good. Because if x is, let's say, minus 5, then the left hand side will, let's say, minus 25. No, minus 5. Then it will give you 5. And the right side, put x equal to minus 5, it gives you 5. Is that okay? So square root of x square is actually mod of x. It's just telling you the length of it. See, once you have done a square, you have lost the information of sign, whether it's positive number or negative number. So you have just squared it up. When you take a square root, you just get the length of it. So you are getting just the length, the magnitude of it, the mod of x, okay? So here I should have, so this way I am going, minus of x over mod of x. Agreed? What is minus x over, what is x over mod of x? What information x over mod x carries?
Minus mod 1.
Yes.
Huh?
Mod 1 minus mod 1.
Mod 1 is 1. Forget minus. Minus is here. What information you have in x over mod x? X, whatever number. Mod x is the length of that number. You divide that number by its length. What remains?
Only the sign.
Only the sign remains. X over mod x knows only about the sign of x. If it is minus 5, x is minus 5, then minus 5 over mod of x, which is 5. So minus 5 over 5 is minus 1. 5 over 5 is 1. 7.5 over 7.5 is 1. Minus 7.5 divided by magnitude of minus 1.5, which is 7.5, is minus 7.5 over 7.5, which is minus 1. It only knows about the sign.
So this will be minus 1 over root 1 over x square when
Then what you said? Sine.
into sign.
Sine of x.
What is s?
SGN is a function which gives you the sine of x. Sine of x. Signature. Full. When you
Is
sign.
that an actual function?
Yeah, that's the actual function. Sine of x. SGN of x. Okay, what is sine of minus 2?
Minus.
Minus 1.
Minus.
Okay, so it will be a number, right? Here it is. What is sine of minus 1.7? Minus 1. What is sine of 2.3? 1. Right? Now understand what was wrong? So this is the derivative of sine inverse of square root of 1 minus x square. Correct. Okay? Any questions? Okay. Let's take another function. Y is equal to log of mod of x. See, if I just write log of x, then I have to restrict x to be positive. Remember that? But now because I have put mod of x, the argument is going to be always positive. But log of 0 is also not defined. So I have put x is not equal to 0. Now this is fine. You understand that? Now let's find out the derivative of this. What is dy over dx? Can you do that? It's simple. Do you know what to do? No? So y is equal to, I will write it this way, is equal to log of x if x is greater than 0. And it is equal to log of, how should I write if x is negative? Mod of x is what when x is negative? No. Mod of x when, so what mod of minus 5 is? Right. Mod of x when x is negative. That is what I am asking. So what is mod of minus 5?
Minus. Yes.
It is minus of minus 5, right?
Okay.
Correct? So it is minus x.
Minus.
Okay. This is what it means to write this statement. That y is equal to this. This statement is equivalent to saying this statement. Now, let's differentiate. So let's first worry only about this part. Let us differentiate y with respect to x when x is positive. So what's the derivative of log of x?
1 by x.
Derivative of log x is 1 over x. Okay? Right? Or maybe I'll write it in 2 steps. It is d over dx of log of x. This is 1 over x. How about negative values?
It's not defined.
No, see, for x negative, this is positive, right? Argument is positive. I have started with mod of x.
But how? But log of minus x is not defined.
No, it's defined. Here x is negative. There log of x, when I said log of x, x was positive. But I am saying log of minus x, but x is negative.
1 over mod x.
Again one.
Use chain rule.
Again one minus.
Chain rule, okay? Derivative of log of u is 1 over u, and u is minus x in this case, times the derivative of the argument. Derivative of minus x is,
Minus
are you following? This is even for x negative. Is that fine? No? Okay, let's, if it is not fine, let's go slowly. Tell me where the problem is.
How do you use chain rule in this?
Okay, before chain rule, is that part fine? Are you okay with this? No?
Yes. Yes,
You have no issue of log being defined for a negative number. It's not defined for a negative number because my argument is positive now. Because x is always negative. Let's say x is minus 5, then this is log of minus of minus 5, which is log of 5. So fine. Let's use chain rule. So log of minus x, right? Define u to be minus x. Then according to the according to the chain rule, taking derivative will mean d over du of log of u times du over dx. समझ आ गया? तो ये क्या हो गया? 1 over u times du over dx. 1 over minus x, u is minus x, times derivative of minus x is minus 1. Agreed? I think you need more practice. You have not practiced. Is this fine? Good. Let's have one or two more before we do something else. What's the derivative of e power x?
E to the power x.
Okay. This is an exponential function. But do you know of other exponential functions? Can you tell me any other exponential function?
E to the power x.
A to the power x. So this exponential function a raised to the power x is to the base a. We can ask what's the derivative of this one. So I want to know what's the derivative of an exponential function to the base a. Do you think you can do it? What will be your first step? Convert this exponential function, which is to the base a, to an exponential function to the base e. Because if you can do that, then you know how to differentiate. Right? How will we do that? Okay, let's. I'm holding a wrong sheet. So first of all, when you are looking at a,
Can you write a little down? It's going a little above.
huh?
Right? Okay. Pull the thing a little down.
Little down is going out of the frame.
No, it's just touching the top.
Okay. So I want to write a raised to the power x as e raised to the power something here. Right? Because if I succeed in that, then I can use chain rule and differentiate the right e raised to the power whatever that is. Right? So let's call it z. What is in the box? Let's call it z. Okay? Now let's take log on both sides. You understand? It's simple. Log function.
Natural log.
Yeah. Let's take natural log on both sides.
Acha, so z is equal to ln a to the x.
Yeah, important. You should remember I am not putting anything here, which means natural log. So it is, what is on the right hand side?
Log of a to the sorry.
Log
This-
of z.
That side. Z.
Right? Log will cancel the e. Or simply, this is the definition, right? What sits in the exponent is what is called log of this. So log of a to the x is z. Very good. I know z now, which means I can write a to the x as e to the log of a to the x. Correct?
Now chain rule.
You can use chain rule now, but before that, I will take x here. Remember, log of a power something is that something log of a. So e power x log a. Now let's differentiate. D over dx of a to the x. You know what's the derivative of e to the x? It's e to the x, the same function. So derivative of a to the x, a raised to the x is almost a raised to the x, except for a small factor because you have chosen a different base. So what's this? If I differentiate the exponential function, I am using chain rule now. Derivative of exponential function is exponential function, same function, times derivative of the argument. What's the derivative of x log a?
Log.
What's the derivative of x log a? What happened? What's the derivative of x log a? You know? X is a variable. A is a constant. A is fixed. So log of a is fixed. A is a constant, right? Are you following? मान लो तुम बेस 2 यूज कर रहे हो तो a 2 हो गया. log 2 is just a number. X is the variable. So this will be, tell me. No, I am asking you, tell me.
Log.
You don't know? अरे भाई, what? Log of a. No? Derivative of 2x is 2. It's okay, it happens. It can happen somewhere. Derivative of 5x. See, that is why you need experience. Just listening is not enough. You have to do more problems. Log of a. Agreed? So what should I write here?
Log of
And what is e raised to the power x log of a?
e power x.
E.
It is this. E raised to the power, this is a raised to the power x. You see, I told you, just like derivative of x, e to the x is e to the x, derivative of a to the x is almost a to the x except a constant factor. Remember, that factor is constant and that is just the log of the base. Is that okay? So if this is true, then it is true for every a. Let's take a equal to e. Choose the base to be e. Then you have d over dx, e to the x. Then it is e to the x times log of e. What is log of e?
1.
Log of e is 1. So this is correct. This is true for everything. Okay? This result you should remember. So d So this result should be in your memory. Let me write first this one. Okay, almost times log of the base. Okay, and that log is in the base e. Okay, that is understood. Is this fine? Agreed? Let's stop here and I'll give you more examples later.